Okay, so we did this part where we learned about displacement time graphs, and now today we are going to do velocity time graphs. Okay, so velocity time graphs have velocity on the y-axis and time on the x-axis. So basically you guys need to remember that velocity time graph gradient basically shows acceleration. So in the first section you might see that's a flat line, which means the acceleration is going to be 0, but the velocity would be constant. The reason for this is because the value of the velocity is still the same all the time. In this one it is going up, which means acceleration is positive and is constant. However, velocity is increasing because the graph line is going up. Is it clear to both of you? Hello Safir, how are you?
Yes, sir, I'm fine. How are you?
I'm good too. Okay. And then in the next one, the line is going down, which means the acceleration is negative and it is constant, but the velocity is decreasing. The reason is that the line is going down, so every second the velocity value is reducing, as you can see from the graph as well. Okay. In this one, you're going to make two tangents, and then from this we know, because the line is going up, so this is positive and this is decreasing, but the velocity here is still increasing, although not as much as it was doing before, but still increasing. Now in the next one, straight line here, it's going up, so acceleration is positive and it is increasing because the gradient is increasing, but the velocity is also increasing rather rapidly. Is it clear, everybody?
Yes. Yes, sir.
Now in the next one, this is the line like this, and then like this, and then like this. So there are three sections. From A to B, the acceleration is positive but decreasing, and velocity is increasing because the line is going up. In the next section, which is B to C, acceleration is negative and it is increasing because the gradient is increasing, but the velocity is decreasing because the line is going up. So the line will tell you what is happening on the y-axis, and the gradient is going to tell you, basically in velocity time graph, the acceleration. Alright, you may draw this, and if you have any questions, please let me know. Okay. Now, so then we also need to know about conversion between them. So before we do that, I just want to give you a small summary. And the summary is that we are basically doing displacement, time, and then velocity, and then acceleration. So what you guys need to understand is that if from displacement time graph you find out the gradient is gonna give you velocity, and from velocity to acceleration, like velocity time graph will give you the gradient to be this. Also, there's one more aspect that we're going to discuss a bit later, where when you go from velocity time graph to displacement, you want to know, then you got to find area under graph, and that would give you displacement when you're basically finding area under graph of velocity time. Now, keeping this in mind, we should remember that we must learn about the graph conversions, and this is one of the tough parts that I believe you should be aware of. So just give me like 1 minute, let me just draw a couple of graphs. And then we're going to discuss them. All right. So suppose we have displacement time here, velocity time here, and acceleration time here. So we'll try to do some of the graphs. Okay, these are the difficult ones that I want to discuss, but you can always, do them if you want to. Now, in the first graph, you might see that the displacement time graph has a straight line and it is going down, just like this, which means that the velocity in this is constant, but because it is down, so we can interpret as velocity as negative and constant. So a negative constant velocity graph would basically be displayed like this on the velocity time graph, because now the velocity is negative and it is constant. Do you guys understand this?
Yes, sir.
Similarly, now in this one we can say for acceleration we have to look at velocity. So here the acceleration is 0. Why? Because it's a flat line, and this line would represent just like this, it will be 0. So because the previous graph gradient is 0, that's why acceleration is 0. Is it clear, everybody? Now similarly,
Yes.
in this section you need to understand, we need to convert it into two parts, A, B, C. So from A to B, we see that the velocity is decreasing and it is positive, right? So a decreasing velocity graph which is staying positive would be like this. Let me draw it good, right? So this means there was a value of velocity, and now this is A and this is B. Is it clear, everybody?
Yes, sir.
In the next section, you see from B to C that it is going, the velocity is getting negative and it is increasing. So negative increase means it's gonna be, we're gonna continue this line like this straight. So that would be C. Now the velocity is not only negative, but also it is increasing in the negative direction. Is it clear, everybody?
Yes, sir.
Now, for acceleration, we're gonna note that it's a straight line which is going down, which means acceleration is negative and it is constant, which means that now the graph of acceleration time would be on the negative axis and a straight line. So this is negative. Yeah. Okay. If you get confused in any of these, please let me know, okay? Alright, now in the next graph, again we need to, because there are two major changes happening, we need to make sections. So A, B and C. From A to B, you see the velocity is positive and it is increasing, right? So velocity is positive and increasing. So the line velocity would be increasing and it is positive, like that. Now you can see the velocity is increasing, the line is going up. Now, so this would be A and this is gonna be B. From B to C, the velocity is positive, but it is decreasing. So you're gonna stay in the same quadrant, but it is now going to decrease like this. Is it clear, everybody? What? Oh no. Okay, I'm sorry. My app was, for some reason, it started updating. Okay, never mind. So you have any questions, or should I go on? Okay. Alright, so now what you're going to do in the next section, in the first section from A to B, the acceleration here is positive and it is constant. So I'm going to make a line like this. So this is from A to B, and then the acceleration becomes negative and constant. So now we've got to shift this line on the negative side, and we're just gonna make a dotted line just to show that this has been shifted. So this would be C. Is it clear, everybody?
Yes, sir.
Good. Perfect. Okay, you can basically copy this up because I will give you an assignment today where you have to solve different graphs. Okay. Okay. Now there's one thing I just want to tell you, okay, and just remember, this is just for your, just write a note here because you should remember this. In case you have a graph that is represented by y, which is against x squared, okay, so you're drawing a graph. There is y and there is x. So this graph line will always be like this. It will be increasing sharply. If there is something like y is proportional to under root x and you have to draw a graph of axes of y and x, then this graph will always show you something like this, and that is an under root graph. Is it clear? So just note this because a lot of times they're gonna ask you in MCQs and you should know what are their trends, okay, just by looking at it. Now then we're gonna go towards graph of rebound, and this is so important because a lot of times this graph will be given, and I'm going to make two sections. Like for example, in the first section, say the initial velocity was 0, it was falling down onto some hard surface, and at this point this object had velocity v, okay, and this height suppose is h1. Then when it rebounds, this object is gonna go up, the initial velocity is u, and I told you final velocity was 0, and the height, let's say, is h2. Okay. Now how do you really make the graph for this? Let me show you. So this would be like this. You just need to remember that the acceleration due to gravity, if you take g as positive 9.81 meters per second square, it could be any other g of any other planet, doesn't matter. So initially, let's say this is A, just to give a reference, this is B, this is C, and this is D, okay, just to give some points. So at A the velocity was 0, at B the velocity was v, so this is a velocity time graph, by the way. So you got to make a straight line like this. This is A, this is B, and the velocity here was v. Okay. Later on, basically the direction of the graph shifts because the object was falling down and now the object is going up. So you got to make sort of a slanted line to a new velocity that's minus u, because this would be minus if I take everything down as positive. And then this would end up right here. So this is point C and this is point D. And here the velocity is 0, as you can see. Okay, so this is the graph of that. Now this area that you see is h1, and naturally the section is larger because the height will be more. This is h2. And if you look closely, you will see that these two lines from B to C, there is certain amount of time difference. So this is the delta t. Okay, this delta t is the time of contact, which means that within this time it was basically changing its direction, and it had it was on the surface. Is it clear, everybody?
Yes, sir.
Okay. Now if you find the gradient of the graph from here or here, the gradient will be g. The reason is that shows the acceleration, and you guys need to understand g will remain same. Hence, both solid lines will be parallel because they need to show the same gradient. That's why. Is it clear? Ramin, Aisha, Umar, Safir?
Yes, sir.
Yes, sir.
Javeria, okay. Now, if you take g as negative, the only difference it would make is it would flip the graph. Like A and B will be down, C and D will be up. Nothing else will change. It will just be a mirror image because you just took a different direction, that's all. Understood? So make sure you remember that. Okay. Now keeping that in mind, we also need to know finding area under the graph. Area under the graph of velocity time, I'd say. So area under the graph velocity time, basically, like I said, it would give you displacement. And now there are certain cool tricks. So suppose for this one you need to know a couple of formulas. Okay, the first formula you should know about a square, which is length into length, a rectangle, which is basically length into breadth, a triangle, which is half into base times height, and a trapezium. So you should always remember the formulas, which is half times height times sum of parallel sides. Okay. So imagine, let's take the similar example because you will be required to do so. Imagine a graph is given like this. All right. Now they have given certain quantities. They say this is velocity in meters per second. This is time in seconds. This is 5 seconds. This is 10. This is 12. This is 14. And this is 16. Okay, so they have given you like this. And here it's 30, and that's negative 20. I'm just supposing, okay? So what you're going to do is that section by section we're going to deal with this.
Sir, can't we do this as a whole trapezium?
Yeah, we can do that too. That would be much easier, right? But it doesn't matter. Whatever you use, it's fine. So for the very first section, if you break it up, this will be half times 5 times 30. For the second one, it is going to be 5. 10 minus 5 is 5 times 30. For the third one, it will be half times 2 times 30. Okay, so you can do that. So I'm going to write this as separately, and then I'm going to write, like, this is a triangle, so we could just take it as one figure. Wait, instead of that, we could just take it as 4. Or alternatively, you can use the trapezium rule, trapezium formula as well. Doesn't really matter. So for 4, I'm going to write half times, the base was 4, the height was 20. In fact, I'll write minus 20 because it is in the negative direction. Okay. So when you add all this up, it's gonna be, I think, 0.5 times 5 times 30 plus 5 times 30 plus 30. Okay, so it's going to be 225, and this will be 2 into minus 20. So that's gonna be minus 40. Okay. Now let's look at it. If he says find the displacement, because displacement is a vector, so we're gonna add them up, keeping the signs up. So displacement will be I think 225 minus 40. So displacement is going to be 185 meters. However, if they say distance, because distance is a scalar quantity, so we're gonna ignore the signs, and then we just need to add them up. So that's what you need to remember, because this shows you why displacement and distance are different. So this will be 265. So the total distance moved was 265, but the net displacement was 185. Is it clear, everybody?
Yes, sir.
Yes, sir.
And because
Yes, sir.
ramen is sharper, you can use trapezium. It would give you the same answer. Doesn't matter. You want me to use the trapezium area?
Yes, sir, I did that. It's the same answer.
Yeah, it will give you the same answer. Okay. Now, not only this, but it could also be a graph that might not be exactly a regular shape. Okay, and that happens a lot. So before my streaming PC laptop battery ends, wait a second, let me plug it in. Okay. Now, so in this method, we only need to estimate, because we cannot find it. So estimate the area of irregular shape. What you gonna do then? So suppose you have a graph like this, and now the graph looks like this. Okay, I don't want this. Okay, like this. And so whenever this sort of graph will be given, they will also give you a grid against it, so that you can estimate using the boxes. Now the best method to do this is by counting the boxes, but you can also convert this into different shapes, like trapeziums and triangles and rectangles, whatever suits you best. But I would still recommend that you count the boxes, because the examiner actually does the same thing. So the answer is given in a range, so you will always fall into that if you follow what I'm doing right now. This takes a lot of work. Okay. So now we have velocity, time, velocity in meters per second, and it's given like this: 4, 8, 12, 16, minus 4, minus 8, minus 12. Here you have 2, 4, 6, 8, 10, 12, 14, 16. I hope I have not missed something. Okay. So the first thing you guys are gonna do is find area of one full box. So if you do that, you see one whole, you can take any box. So one box is basically 2 on one side and 4 on this. So 2 times 4 gives me 8 meters. Do you guys understand how I did this?
Yes, sir.
Now what you're going to do is count number of full boxes. When I say number of full boxes, those means that basically, so what I'm going to do is I'm going to separate the two shapes. So I'm doing for the first one, the above one, right? So this is like 1, 2, 3. I'll take it as full: 4, 5, 6, 7, 8, 9, 10. Okay, I take it as 10. And yeah, I think that's fine. So there are 10 full boxes, and then I'm gonna count number of half boxes. So half are those which are partially or cut like this. So 1, 2, 3, 4, 5. I'm gonna include this one as well. 6, 7, 8. So it should be like on the best of your judgment, basically. So it's 8. Now you might be wondering why I have taken this small box, but I have completely ignored and I've also, the reason I've taken this, because you see, if I take this as half and this one as half, then these two will combine to be one full. Do you understand? This means that if I combine half boxes together, they are going to be approximately 4 full. Is it clear? So just
Yes, sir.
like combining 8 half things means you combine them, they will turn out to be 4 full. So now total, okay, by the way, the meeting will end, you got to rejoin the same link, okay? Total boxes now are 10 plus 4, 14. Okay, now I'm waiting for the meeting to end, and then we rejoin. Okay. So yeah. Okay, now so the next thing you're gonna basically see is that I'm gonna change this. So I'm gonna say, okay, if one box had an area of 8 meters, then 14 boxes will have an area of 14 times 8, which basically makes up to
112.
112. Very good. Meters, right? So we got the area of this. This is 112 meters. Okay, then for this other one, we can quickly do this. So I'm just gonna put it like a line here so that we can just write it on the other side. So for this one, I think only like 1 and 2 boxes are almost full, and the half boxes here are 1, 2 and 3, which makes it 3, so that is equivalent to 1.5, right? So the total boxes of the other shape is going to be 2 plus 2.5, that's going to be 3.5, right? So for that shape, it will be one box equals to 8 meters, then 3.5 boxes will be equal to 8 times
14.
28.
Oh, yeah.
Okay, 28. So this is 28. Okay, now if they say what is the displacement, you write displacement is 112 minus 28, and that's gonna be 84. And for distance, it is gonna be 112 plus 28, that's 140. Everybody understands this method? Not that hard, right? So generally, the ideal way is that you always, I mean, don't waste too much time. You can do it like a little bit carelessly, but not too much. Okay. Let me see if there's something else that we're gonna do.
In the second shape, why is one box 8 meters?
Because if you just find the area of one box, right? This is from this side, it is 2, and on this side it is 4. So 4 into 2, 8. Do you understand?
Oh, yeah, okay. Yeah.
Yeah, so one complete box is 8 meters, but then we have to count the number of boxes. Okay. So I guess this is probably it then, right? And inshallah, from the next class, we're gonna start off with projectile, and then I'm gonna give you a worksheet. Okay then. Have fun. Bye.